Hello everyone, and thank you for being here on this early Sunday afternoon. I would like to give you a little presentation, but first a little introduction. We are Open 3D Engineering from Berlin. My name is Bram de Vries. This is my colleague Maurice Winkler, who will do the second half of the presentation. And our third man is Hugo Silva, who is currently in Portugal for visiting his family. And our work is to work on open hardware, to improve it and to promote it. And the last year we worked on 3D printers, and we developed our own redesign of a wrap, the Prusa i3, and we redesigned it into the i3 Berlin. And while doing so and also producing this and basically selling it, we run into quite some challenges that I would like to share with you. There's one problem with hardware compared to software, and that is that copying hardware just takes a lot more time and a lot more money than it is the case for software. So you run into some difficult points when you go through the whole cycle of developing your product. So it all starts with the design. So you start thinking, okay, maybe I need a clamp here to hold this filament because it's so messy. And then you design this file, but it should also actually fit. And it should not only fit on this printer, but it should also fit on a different printer. So you have to take care of tolerances and things like that. And maybe you have several different ideas, so you have to keep track of that. So also to share and inspire other people. So you have to track your versions and make log files, basically, which is kind of the same as in software, I think. And after your idea basically settles and it becomes all real, then you have to also document it, because it's not press the install button and there you have a functioning product. No, you have to put it together, and people have to somehow find the right screws somewhere. And this all has to be documented to include other people and users also into your project. What it becomes even more difficult is to manufacture. Like I said, screws cost money, and they cost a little less money if you buy a whole lot of it, but then you also have to be sure that if you want a 3D printer, that I have these screws in my place, and then you run also into delivery times and things like that. This all has to be organized, and it's a challenge. And then you have to sell it, which is also boring. And then you have to manage the quality. So also, does the printer still, which is a mechanical device which moves, so things wear out, and does it also still work a month after? So this is all a lot of problems that has to be managed, all centered around your core data, which is the 3D printer in this case. Of course, these problems are not new. I would like to tell you a little bit about the PLM concept, or Product Lifecycle Management concept. This comes from the car industry, from American Motor Car Corporation, from Chrysler and all these big brands. When they developed in the 90s one of the first SUVs, I thought it was the Jeep Cherokee or something. They had the aim of innovating faster and cheaper. And to do this, they wanted to have a very big information backbone around the whole product, so that the engineers designing the product, and also the engineers responsible for manufacturing, and also the people responsible for selling, the whole team of people involved in this project knew what was going on and could influence it. And it was very efficient, because they could do basically the whole development in half the time for half the money. And it's actually quite funny, because such a big company is a kind of open source microcosmos, where it's really focused to share a lot of this data, of course, until the front door, and no one should bring it on the street. But inside of this company, it's to make it more efficient, is to share a lot of data. So I think we as open source people can learn a lot from that. And of course, the bigger your project gets, also the more data has to be managed and the more difficult it gets. And if you have a very small project, it's not so difficult. We have a kind of a medium, simple project of a 3D printer. And in the next part of the presentation, Morris would like to tell a bit more about how we try to implement this in our project.
Hello, my name is Morris, and yeah, first I would like to say a few things. While we were talking with other open hardware projects, we realized that there's actually a lot of problems regarding this, how to manage your source files, how to manage your production cycle, and that there is not really a general solution. And when we started to invest time into this project and started to look how to structure this, we also realized that it has to be very customized. So you can have a basic template of an idea, but you can't have really a tool or one tool that will manage all of this for you, because every project is very unique and has very unique dependencies, very unique needs. And so I think in the end, everybody has to find his own approach to this, but we want to show an example how we do it, and I think it can be layout also for other projects to start this. So basically, when we do our design process, we have a few main types of files that come out through the design process. So we design mainly in Blender. It's an open source 3D modeller. So in Blender we design the parts that we print on the printer. So there's many parts on the printer that are printed by the printer itself. We make the whole assembly in the Blender file. So we have all the parts in the Blender file, and we already check if it actually can be assembled and how to assemble it before we produce it. We check how many parts we need, so we have some tools in Blender to count actually how many parts we have in here, how many parts we need to create this printer. And we use it also for documentation. Yeah, but I will come later to that. Then we have cut files for the frame. We are milling the frame, so we have cut files that we can use to feed in a CNC mill. We have firmware, which we don't produce our own firmware. We don't write our own firmware, but for 3D printers, you basically have like 5 flavors of different firmwares. And what we do, we pre-calibrate, because there's lots of settings in a firmware, and we pre-calibrate this firmware to our printer. So if you want to use it, you just download the firmware from our repository, and you just install it and you're ready to go. And what we also have are settings. So because there is a lot of different tools to take 3D models and translate them into what's called G-code. That are the commands that the printer can understand and interpret. And these tools, they have a lot of different settings, so it's very difficult in the beginning to start using them. And so we have presets of settings that we give out to our users, so they can start right away printing with the printer. There are some, what we basically do is digital fabrication. So everything, when we start everything, it's a file on a computer. It's created with a program, and it has really, yeah, it has some very nice parts on it. So basically, you have files, you have directories. It's very structured. You can find things. Other people can find things also. You're ready to go to a bigger manufacturing process. So you have source files that you can send to a company or to somebody that has bigger manufacturing capabilities, and you can start processing them right away. So you don't have you don't spend a lot of time to scale up. You can have tasks that are assigned to different people or different individual team members, but still everything can be reviewed by everybody. Yeah. So, for example, Bram is the mechanical engineer in our team. He's doing mainly the mechanical engineering, but every time he changes something, I can have a look and look actually what did he do, and I can review it and give him some feedback on that. That's very nice. So, to structure all this, we use Git. It's a very nice tool. It's decentralized, so basically it's very difficult to lose information. Everybody has a copy of everything. So only in the case that when everybody loses it at the same time, you will lose all your information. We have commits that help us understand what actually happens in the repository. So if somebody changes something, he gives a little comment, say, look, I did this and this and that. So we actually know what's going on at certain moments. You can branch out. So if somebody say, look, I like this printer very much, but I think I can do it in a different way, or I can improve something, you can create derivats, you can fork it, branch it, whatever. And we have tags that help us creating versions. So we can take a certain moment in time and say this is version 1.0, it's stable, and you can use it. We don't use Git right away. We use GitHub, which is more tool for software, but it's basically really the same. You have just source files. And GitHub brings a few nice tools with it. So in GitHub, we have desktop clients that facilitate the use of Git because, well, we have I myself am a software engineer, but Bram is a mechanical engineer. Our third member is an industry product designer. So they are not all very used to use version revision systems. So it facilitates a lot of people to get into Git. Then we have the issue tracking on GitHub that we use ourselves to track issues with the product. And our users can also come and say, look, you have a problem. They can even say we have found a fix, or at least we know there is a problem. We use the wiki pages very much in GitHub. We use them in ASCII-Doc, which allows us to export them after doxygen and generate all kinds of documentation formats from this. It's very, very useful. And well, we can do releases in GitHub and add additional information to the releases. So that are the reasons why we choose GitHub over Git repository on our server. Documentation is a very important point because when you have an open hardware project, you want to get it out to people, you want that people use it because you will find problems that you will not have seen before. So if you want them to use it, you really have to document it. You have to tell them how to use it, how to create it. And it's, we very much try to automate it. So we have it, basically our documentation comes mainly out of the Blender file, which makes the Blender file sometimes even a little bit messy, and sometimes even a little bit difficult to work with, but on the other hand, it takes a lot of time off from the documentation process. One very, very important part in documentation for hardware projects is the so-called BOM. It's the bill of materials. A bill of materials basically is a spreadsheet where we say I need, 2 screws of this kind, 2 bars from this kind, and a good BOM also lists prices and places where you can buy this stuff. So if somebody wants to recreate a project in another place, I can order this stuff there, this stuff here, this stuff there. But also it helps us a lot to keep actually track of what we need to create one unit. So for example, we change something in the Blender file. The BOM and the Blender file are linked together. And this is also in professional computer-aided engineering. This is taken very much care of because you tend to make mistakes. If you have to do this manually, if you change something in the Blender file, and after you think, okay, I need 4 more screws of this type, and you have to add it in the BOM file, you tend to forget about things, or you have communication problems, and it's really nice if these 2 things are linked, because you know actually all the time what you need to create one unit, also if you change things. And then what we have also in the Blender file is the assembly. So basically you have frames in Blender. They are used for animation. And we basically start with frame 1. And in frame 1 you have the first 2 parts that have to be assembled. In frame 2 we have the third part, it gets added to it, and so it goes on and on and on and on. And I think somewhere about frame 100, you have a completed unit, and we use this, render these images in Blender, put them into the GitHub wiki, and then we document this with text, yeah? And so we create our documentation. So this helps us a lot. If we change things over time, we can very quickly adapt our documentation. We have a make file that exports all the frames from the Blender, and well, the text you have to edit manually, but it just makes the process much more liquid. And then from the GitHub wiki, you can browse it directly on GitHub. You have the documentation there, but we have also the possibility to use a tool that's called GitScribe that will convert the ASCII doc on GitHub into Doxygen, and from Doxygen you can go wherever you want, PDF, HTML, EPUB. There are a lot of formats you can export directly from Doxygen. So yeah, it's very helpful for documentation, and I think it cuts us down half of the time for documentation. We still need a lot of time for documentation, but yeah, we are a very small project, so we really have to look for this. Yeah? I think for the last documentation we took all together 1.5 months to put it really together. It's a lot of time, but documentation always takes a lot of time. Resource allocation, this is when you actually create the hardware. You have to think about how many parts I need, where I get them from, or how I manufacture them, or how I do them myself. And well, we have basically, again, the Blender file here. In the Blender file, we have certain layers where are all the printed parts, and we can just take these layers and export files that we print on the printers. So we take care of that in the Blender file. We have the cut files where we create our frames. There are all the measures for the frames, and we mill them. And then we have again, the most important tool for that is the bill of materials, because it's already a spreadsheet, and so we basically work with a lot of other spreadsheets. We pull it into other spreadsheets and kind of manage our stock with it, or when somebody comes and say, I want to have 10 printers, you can really fastly look in what do I have in stock, what I actually still need to order, or what do I need still to manufacture myself to actually deliver these units. And yeah, it helps a lot if this gets a little bit automated. It's so specific to every project that it might be difficult to automate this, but till now we only use spreadsheets for this. We haven't found any tool. All the tools that are available, they're so complex that you spend three times more of time to use them actually than the time you get out of them. So this is the part where it gets very, very specific to the needs of the project. Yeah, just as a note, we have 284 parts currently in one printer. So we have to take care of all of these parts that they are basically in stock. Yeah, sales. Well, you can bring out your hardware in many different fashions. When we started, we decided on workshops. We wanted to do workshops, and I think it's a good way to start with workshops because you get immediate feedback. Okay, I'm hurrying up. You get immediate feedback. Workshops are really good because you experience feedback that you won't get in other way. We have also feedbacks through people that write us tickets. We have feedbacks through people that send us mails. Sometimes they phone us, and so we have this feedback. In a workshop, we have a 2-day workshop where we every month have around 10 people going through, and we really see where are their difficulties. We see where are the difficulties with assembly, where are the difficulties with installing software, where are the difficulties in using the printer. And so this is a very good feedback. We have, at some point we created an online store. This was because we got a lot of requests from people if they want, if we send them out kits, because they couldn't come to our workshops, so we decided to do an online store that's, well, very time consuming. You really should think about if you want to create something like this. And since 1 month, we also sell them in a little store in Berlin that sells 3D printers. But of course, there are many, many other ways to get out your hardware, but you should think about ways to get it out because you want people to use it and you want to have feedback that you otherwise won't get. Yeah, so quality management, that's basically about the feedback. And we have a lot of direct contact, and I really liked it. I really like the direct contact because it gives you this kind of feedback that you don't get. Yeah. Also, we still have a lot of private contact with a few of our customers that we meet, and they tell us about their experiences. We have, of course, the ticket system. We have mails. We have and we have long-time tests. So once you actually produce the machine and you work over time with it, you will find problems that occur only in long time. That occur only if you use it 6 months or 8 months. And well, all this information gets compiled, and we do two things with it. We enhance the documentation, because you get a lot of ideas out of it. For example, we try to make the assembly more easy, more organized, more simple, less steps. Sometimes you have steps that you do later that you should have done earlier, but you don't realize until you see somebody doing the steps. We have frequently asked questions because there are questions that come up all the time again and again and again. And so you should provide people with answers to that. And what is the outcome of it? It's like the place where the circle closes and you go back to the drawing board and you realize, okay, this thing can't stay like that. We have to change it. So you go again into redesigning or designing parts of it, and you go all over and the circle starts from the beginning again. So far to quality management. This is your part.
Yes, so that was our story on how we try to make this not so easy project into a kind of organized structure with as little mess as possible, which of course takes a lot of work, so there is a balance. You cannot overstructure because then you cannot do your work anymore. And while doing this, of course, we have some ideas how we want to improve ourselves, and also what we can say to other open hardware projects. First of all, design sharing is a critical note to ourselves. Is we should take more care to have it really accessible for everyone. We use some special screws. We use CAD software that is quite unusual, Blender. But also we want to share not only on our Git, but we should also share it on bigger platforms and in bigger communities, so there's bigger chance of other people coming in. And then of course the whole documentation becomes more important. That's also the other thing that we want to do. There is a lot of talk about documentation in the open hardware community, and there is still not the holy grail has not been found yet. Because contrary to software, in software you can just write in things because you're writing anyway. And in hardware, it's not as simple as that. So documentation is just a lot of extra work. And so that's also why we want to write more about our documentation system for others to learn from. And last thing that we want to do is to look for or to develop some kind of database and other tools, especially for our stock management, because this consumes most of the time. So to write your bills and to see if all the screws are there and which is annoying. And this all we want to do because it's really needed for open hardware projects, for good quality open hardware projects. So small initiatives like us have a better chance in competing with bigger, more commercial propriety companies. And we think that's good because it's nice to have your own company and to do stuff that you like. That was basically our presentation. We have some minutes left, so we would really like to hear from you some questions or comments or things like that.
Any questions?
Are there any questions?
Don't be shy. Any questions from the internet? No? Anyone else? Come on, you gotta have.
Was
Please,
that
wow.
clear?
Was it that clear, really?
Cannot imagine. Is there
Wow.
something else that we have to say?
Well,
Excellent. Thank you very much. Microphone number 1.
One thing I was wondering about, like, what kind of people are working with your 3D printer, developing it? Are you just like a computer scientist, or also some mechanical engineers?
The people using the printer?
No, like your group.
We are 3 people. I'm mechanical engineer.
Alright.
Software is a software. Morris is a software engineer, and Hugo is an industrial designer, more for the looks and about stuff. So we have quite an interesting team to work on something like this.
And so, do you get along well with the version control system? Because, like, I'm a member of a robotics club at our university, and sometimes our mechanical engineers really mess up stuff, mess up the history. Was that easy for you to like get into it, or?
No, it's not easy. It's it's difficult. It's always from different disciplines. You have always different ways of organizing your work, and it also comes with personalities. So that's difficult.
Do you think there's something that could make it easier to get started with version control systems, or is it?
I mean, that's why we choose GitHub also, because you have desktop clients, or we also use Sparkle Share a lot, where you just throw things in and take them out, and you don't have all this command line Git craziness there. And a lot of people have problem with this, so we like to use tools that work on top of that.
Yeah. And how does that work with the Blender files? Are they binary or are they text-based?
They're binary, as far as I know.
So your Git history is getting really big with the binary files?
I think so.
It's okay. We compress it a lot.
Oh, okay. And do you think there's like any possibility that one day we could have something like diff for like mechanical files, like that you could use the differences in?
Well, you have diff already for mechanical files. If you use OpenSCAD, you can diff them very easily.
True.
But well, I don't know any CAD software that you could diff in any way. It might be possible for Git to write, there's an approach to write a diff tool for Git that use Blender files, but well, I think it's can be very difficult. And usually it's like this, that you have somebody that, or you have a small group that is dedicated to do this stuff. So you don't really need that so much. It's more, it makes more sense if you have a bigger group to write actually a pipeline system that they can work together in the CAD software. Yeah.
Okay, thank you.
Hello.
Hello, Rolf. I'm Rolf, engineer. I was a little bit surprised. I expected to hear something about agile and non-agile development, about using MS Project or open source project software and so on. And now I see that you use Git, a sort of backlog in the means of agile software development. So that's there where you put it and take it back. So also PLM software is organizing the professional one, the Siemens and so on. They use their system to handle all the design, so the CAD stuff in its its databases. And if you now come as the guy before me and use a text-oriented thing like Git or any CV system for binaries, where you have then to import again into your Blender and so on, I'm a little bit surprised. So please tell us about the project management, where usually the people use open source or not open source project tool. Do you use something like this tool or not?
There are, look, if you look at professional PLM systems, and if you look at the open source, I looked through a lot of, or actually through all the open source systems that are available, and the problem with them is that they are all so complex that they eat up more time than they give you. So you spend so much time implementing the system, getting everybody used to it, actually filling out all the forms that you have to fill out to enter one part into the PLM system, that you spend like 3 hours and winning 20 minutes. So it makes no sense. So I think for a small project like us, a lot of open hardware projects are very small, it makes much more sense to simplify that stuff a lot. To make it as simple as possible, because you don't have the time to spend so much time on organizing your PLM. Yeah?
I heard about the University of Hanover, where the very unusual AutoCAD was taken as standard by a group of Formula students, so they build a racing cars. It's a non-commercial project, and because this AutoCAD system allows them to, like GitHub in the software world, to take parts out and then in a sort of simulation to put it together, while other CAD processes and PLM systems of the competitors, which are even very expensive and so on, they don't allow this. So you can't, so the collaboration of work was with this AutoCAD system, which nobody in the mechanical engineering likes AutoCAD, but this was the argument again to take AutoCAD.
Yeah, but this is called this is called pipelining, yeah? And pipelining, you could implement pipelining into Blender. Also, there are studios that use Blender that have a pipelining system for it. And pipelining, basically, you have parts, because in a Blender file, on a CAD file, everything has a tree structure. So you can go into this tree structure, grab out objects, and push them over to somebody else over a database. This is completely possible. There's just no tools like this for Blender. There are tools for this for AutoCAD, for Alias. There are a lot of tools for this. For all the professional inventor systems, they have that. But there's no open source system. And in 3D modeling, there are a lot of pipeline systems, but they're all customized. You won't find a pipeline system that works for everybody the same. They're all customized to the certain studio that uses it. But it's completely possible.
Then I misunderstood you. So it's important for you that you have an open source software design process and the result is open source, and not just to say we get money by open source, because open source must not be unpaid. That's why we use professional tools which are proprietary, but the output, what we work for, we demand by our customers that it is open source or whatever. So you have, everything must be open source, right? Or may the customers take your results and build proprietary products where you are paid and they get the sources, but they don't say, no, we don't share it with our customers, because nobody who buys a washing machine wants the open source code of the machine.
Did you get?
I'm sorry, we're running out of time. So if you'd like to, you can try to pursue that question outside.